Hello there, ROS developers, and welcome to a new open class. We are today in open class number 166, and today we have an open class which is a little bit special. So we are going to be talking about Snap and how to distribute ROS ROS1, ROS2 applications using snaps. And I have seen already a couple of comments there in the chat from BP saying hello, and also from Amna who says rosject not available yet for me. Okay, don't worry because that is normal. Okay, so today we are not going to be working as usual with a rosject. Okay, then yeah, let me already switch to my computer screen so that I can explain how it's going to be today's open class. It's going to be a little bit different from usual, but as always, please let me know first of all if image is fine, sound is fine, you can hear me properly, so that we can continue with no issues doing the class. And let me switch already here to my computer screen. There we go. Let me move to the open class page here. Dave says that sound is good. Also Amna, everything is fine. Okay, perfect. Yeah, so as you can see, today we have no rosject here as usual, because today we are going to be working directly with a course. Okay, so what I suggest that you do today, okay, is to leave this streaming page here opened and then open a different tab, like I'm going to do right now. Yeah, so I'm going to open here in a different tab another page of the construct. Okay, I'm saying this because yeah, so because we don't have the rosject today, we don't have this streaming panel and everything. So the streaming, you are going to be able to follow it from here, from this page, from the main page, yeah, of the open class. Then just leave this page open here in one tab and then open another tab, which is the one that we are using. We are going to be using for the work. Yeah, does it make sense? Then the course that we are going to be working with is this one. Yeah, Distributing ROS Apps with Snaps. Okay, you can search it here in the using the search bar if you want. You are going to find it easily. Okay. Yeah, so I'm going to open the course right now here by clicking on the Start Course button. Yeah, if you are in the main page, you can click here also on Start Learning, and this is going to open the course. Okay, so all of you, please go ahead and open this course as I am doing right now. Okay. Yeah, so let me repeat it. What I recommend you to do today is to leave the streaming page here opened in one tab, and in the other tab open the course. Okay, so this way you are going to be able to work here in the course page and follow what I am doing, etc. Try the different examples that we are going to be seeing today, and at the same time you are going to have access here to the stream and to the chat and everything. Okay. Yeah, does it make sense? Are you already opening the course? Perfect, says Bipin. All right, so also Amna says yes. Okay, great. So there shouldn't be any issue, because this course so far, as you can see, it has only one unit. Okay, and this unit is free, so it's accessible for everybody. So so yeah, there shouldn't be any issue accessing to this unit of this course. Okay, then so far this course contains only one unit, only this unit, but of course in the future we are planning to keep adding more units. Okay, so this course, as you can see, basically it's titled distributing ROS applications with snaps, okay? And this course has actually not been created by us, but has been created by our friends at Canonical, yeah? So Canonical are the developers of Snaps, of this Snaps tool, yeah? And they are the ones that have created this course, okay? So before starting, a big shout out to the guys, our friends at Canonical, for creating this amazing course that it's going to allow us to know better how to work with snaps, and in this particular case, how to use snaps for creating and distributing very easily ROS and ROS2 applications. Yeah. So I don't know if you are familiar with snaps. Does anybody here in the chat know or has worked previously with snaps? Yes, no? Nope, says Bipin. Okay, yeah. So me myself, I'm very far away from being an expert about the snaps. So this is also the reason that for today's class, I prefer to just have a look at this unit. Yeah. So don't worry if you don't have any experience or you don't know what snaps is, because what we are going to be covering in today's class, it's basically the very basics. Yeah. So we are going to see what is a snap, and we are going to do and try some practical demonstrations. But the main idea of today's class, yeah, the main goal is to get this general overview of what are snaps and how can we use them. Yeah, how they can help us in our robotics development. Yeah. So yeah, as you can see, as your course loads, you are going to come directly here to the first unit of this course. Yeah, and if you are used to work with rosjects, you are going to see that this is very similar. Yeah, so here in the left side, you have the Jupyter notebook, you have the IDE here, and you have 4 different web shells down here. Okay, in this case, we don't have a simulation because for today, we are not going to be working with a simulation, okay? So this is why we don't have any simulation open here. Yeah, today we are going to be working with the IDE, the notebook, and the shells, all right? Okay, great, then let's start. So let's start by covering, first of all, what is a snap? Yeah, so basically, a snap is a solution to build and distribute containerized applications, in this case, robotics applications, yeah, in an easy and fast way. Okay, so basically, it offers a solution to containerize ROS ROS2 applications, and it allows you to distribute it in a very easy way, yeah, without having to worry about the dependencies. Well, I mean, the developer, the one that creates, or the team that creates the snap, has to take all this into account while developing the snap. But once your snap is developed, you can provide it to your clients, to whoever you want, and they are going to be able to use it in a very simple way. Okay, so basically, it's a solution that allows you to containerize your application so that you can distribute them in a very easy way. Yeah? Then this course is going to cover many things, so I'm not going to go over everything, but so far we have this unit here, so we are going to focus on the very basics. Okay? So, yeah, so it can be used for ROS or ROS2. For today, we are going to be focusing on ROS2, but you can also use it for ROS1. Yeah, in case that your robots are working with ROS1, you can also use it for ROS1. Okay, Then, what is a snap? Yeah. So, as we have said, a snap is a containerized solution. Yeah. So, snaps bundle all our dependencies and assets in one package, making our application installable on dozens of Linux distributions and across distro versions. Yeah. And you, of course, you won't have to install anything else on your robot's operating system. No dependencies, not even ROS, etc. Okay, so everything is going to be containerized inside the snap. Yeah. Then there are other things, of course. So you can use strict confinement in order to have a good security for your snap. Okay, I don't know if we are going to get until the point to talk about this security, about confinement or not. It can be integrated into continuous integration, continuous deployment pipelines, of course, and other things, okay? I don't want to go over everything because it would be too much, but basically you get the idea, yes, of what is a snap and what advantages can provide to your robotics development, yeah? Then, what can snaps do for our robotics applications, yeah? So, snaps aren't meant to deploy software that has been developed and tested, okay? So, before creating your snap, you have to be sure that the application that you are going to provide is working, right? So, you are going to have an initial phase where you develop your packages, whatever, you test them, and you make sure that they are working, right? Then, once they are working, you can pack your application inside a snap and distribute it in a very easy way, okay? But before building your snap, you have to have an initial phase of testing and making sure that your application is working as expected, okay? So snaps offer a solution to deploy and distribute your software, okay? But what can't snaps do for your robotics application? Snaps are not meant for testing and debugging, yeah? So as I have just said, snaps are meant to be used once your application has been 100% tested and is working, okay? Then once you are sure that your application is working, then snaps come into place because you can build your application into a snap and then distribute it to your clients, to whoever you want in a very easy way, okay? So snaps are not meant for testing, debugging, and developing, okay? Are meant for distributing or deploying an application that is already working, yeah? Does it make sense so far? Are you getting the general idea? Yes? No? Yes, says Chelsea Star. Okay. Also Mohammed, Bipin, yes. Okay, then let's keep moving. So, so in most Linux systems, okay, Snap is going to be already installed, okay? In our case, we are going to go here, in this specific case, we don't have it installed, so that we can show the installation steps also, yeah? But very, very simple. We are going to run the sudo apt update command in our shell, okay? You can copy it directly from the notebook, like this, with Control-C, and then paste it here with Control-B, okay? So let's do first an update, and then we are going to install snapd. Okay? This shouldn't take a lot of time. It should be done in a few seconds. There we go. Now, to make sure that we have Snap installed, we can run the command snap -- version. Okay, and here we can see that we have Snap installed in our system. Okay, we can also try the snap help command in order to get some information about the different command lines that the Snap provides. Okay. Yeah. So far we have installed snapd. Yeah. Then snapd is used to download and run snaps. Okay. But there is another tool which is Snapcraft, which is the one used to build the snaps. Yeah. So Snapcraft is used to build a snap. Yeah. Once your snap is already built, you can distribute it, and then in order to run it, to download that snap, you use the snapd command, right? So let's install now this Snapcraft tool. Yeah. So let me copy it, in fact, directly here from the notebook. Control C, Control V. Install Snapcraft Classic. Yeah. This classic flag, basically it refers to the confinement, yeah, to security things that maybe we will cover them later, or if not, you can have a look later by your own. Okay. Yeah, so Snapcraft then is actually not only a tool for building snaps, but it's more generally a developer tool. Yeah, so you are going to need Snapcraft in order to build, to upload, and share your snaps. Yeah, so actually, after you build your snap, you can upload it to the Snap Store. Yeah, where then anybody can go there and download your snap. Okay. All right. Then once that we have everything needed installed, we have installed snapd, we have installed Snapcraft, we are going to go and create our first snap. Yeah, we are going to build our first snap. Then for that, we are going to download our repository, which is provided here. Yeah. Then let's go inside the this default workspace src folder. Let me get a quick drink here. There we go. Yeah, and inside the src folder, we are going to git clone this repository. Yeah. Provided by, created by the people at Canonical. Yeah. And as you can see, the repository is actually very, very simple. Yeah. So everything that this repository contains is a license, a README, and then a folder here, which is named Snap. Yes. And inside this Snap folder, there is a YALM file, snapcraft.yalm. Yeah. This YALM file is the file that contains everything needed in order to build our snap. Okay. Then you can open it here using cat through the web shell. You can open it directly by double clicking here so that you can see it here. Yeah. You can maximize then. Oops. Yeah, this is actually not showing. All right, never mind. Let's put it like this. Okay. Yeah. Then if you scroll down, you're going to see that actually it's not that bigger. Yeah. So it's actually a pretty simple file, right? It contains just a few lines, and only with this, yeah, we are going to be able to build a snap a ROS2 and a snap that contains a basic ROS2 application. Yeah, so you can see that the convenience of this. Yeah, so just with this, just with a YAML file, you're going to be able, we are going to do it now. In fact, we are going to be able to create a snap that contains a ROS2 application. Okay. Let me see. I can see some comments here. Is it a kind of Docker for robotics application? Is asking Antoine. Yeah, so the general idea is similar to Docker. Yeah, in the sense that you are basically containerizing applications. Yeah. So yeah, the idea is very similar to Docker. Antoine. So if I understand well, you install Snapd on each robot you want to deploy to, and Snapcraft on your built machine. Well, that's a possible configuration. Yeah, but there are others. But yeah, that's a possible configuration. In fact, there is a video here that we can see. Let me see if I find it. I think that it's somewhere up here in the initial. Let me put it very quickly, because here, yeah. So in section 1.1.3 here of the notebook, you have a link here in this video. Let me click it myself. And this video, it's pretty interesting. Let me mute it here. So this video, it's very interesting because it demonstrates a comparison of a regular installation process of the software that a Turtlebot 3 robot requires, using the regular apt commands and using Snap. Yeah. So here in the left side of the screen, you are going to see how to install the required software to a Turtlebot 3 robot. And here in the right half of the screen, you are going to see the regular process by using apt. Okay? So here we are installing Snap, as you can see. Okay, here in the right side, they are running all the commands to get the keys, sudo apt update, yeah, and so on. Then after that, they are going to install ROS, etc. Yeah. So here they are directly installing a Snap. Yeah, this Turtlebot 3C Snap, and that's it. It's done. Yeah. So here they have already installed this Snap. Okay. This is, as you can see, this is inside the robot. Yeah. This shell is inside the Turtlebot 3 robot. So inside the robot, we have installed a Snap. Okay. Then this is the local machine, let's say. So here in the local machine, we set the ROS master URI environment variable pointing to this computer, yeah, to the robot computer. Very, if you have worked with robots in ROS1, you know about this ROS master URI environment variable, yeah. So we are pointing this shell to this computer, to the computer of the robot, by setting the ROS master URI. Okay. There we are setting it, and that's it. Yeah. So now we are going to already, let me put this bigger. Here we are going to already run a ROS topic list. Yeah. You can see here a ROS topic list, and we already have access to the topics. Yeah. Let me stop it here. Also, you can see that here on the right side, we are already we have already increased the speed, because here we are still installing things and so on. Yeah. So here, by using a Snap, we install the Snap inside the robot computer, and from another computer, we set the ROS master URI variable pointing to the robot computer, and that's it. Yeah, we already have access to the robot topics, and if we want, you are going to see it in a moment. You can already, using a joystick, using a control, you can already start commanding the robot, moving it, etc. Yeah. Meanwhile, here we are still installing things, and actually we are going to still need some more time in order to install everything required by the robot. Yeah. So this video is very interesting, and it demonstrates in a very graphical way the advantages that Snap can provide to your robotics development. Yeah. Okay. Yeah, so I hope this answers your questions, Antoine. Also, Bipin is saying layout 2 is better. Yeah, I suppose that you refer to this. Yeah, you can try different layouts if you want. Here, I'm going to leave it with this one. It's okay. Yeah. Yep, perfect. Okay, so yeah, then let's go back here to where we left. Yeah, so basically we downloaded the repository, which contains a snap folder and a snapcraft.yaml file. Yeah, so whenever you want to create your own snap, you are going to have to create this YAML file inside a snap folder. Yeah, this is the expected structure. Yeah, so the file snapcraft.yaml is expected to be found in the snap directory. Okay, then what does this file contain? Well, let's have a look. It contains different things. Yeah, first of all, it contains a metadata section. Yeah, which is these first lines from 1 to 6. Yeah. This is the metadata, yeah? So it contains the name of the snap, the version, a summary, and a description of what this snap is for. Yeah, so in this case, this example launches a ROS2 talker and listener. Yeah? This is some metadata so that third-party users know what to expect from this snap. Okay? Metadata. Then we have the security model, which is this confinement line here. Yeah. In this case, we have it set to dev mode. Yeah. So dev mode basically allows. Basically, it's a developer mode in the sense that this snap is going to have access to all the systems of the host computer where it is installed. Yeah. This mode is useful when you are developing, yeah. But once your snap is fully developed, it's pretty more recommended to use other type of confinements, yeah, to restrict the access of the snap. Okay, but we will see that later. Okay, I don't want to enter into too much detail because I think it would be too much. Then. What else? So we have the base, yeah? This basically indicates let's say a base snap which contains the most basic libraries and so on, yeah? So in this case, as you can see, we are using Core 22, and Core 22 is the current standard base for snap building and is based on Ubuntu 22. Yeah, so basically, let's say that this provides the most common libraries used in Ubuntu 22. Yeah, so any snap that you create is going to very likely require a minimum set of libraries. Yeah, so this is provided by this Core 22 base snap. Okay. Here, yeah. All right. Let's continue. Then Next, we have the parts section. Okay? This parts section basically contains the relevant information in order to build your snap. Okay? So as you can see, we have here one part, which it's called ROS demos. Then we provide a plugin. In this case, this plugin is going to be used to build our snap. Yeah? As you know, ROS2 uses colcon, right? To build this colcon build. So since we are going to be building a ROS2 application, the plugin selected in this case is colcon. Okay? Other plugins also are supported, but for ROS2, the plugin to build a snap is colcon. Okay? Then what are we going to be building inside our snap? So we are going to be building the contents of this repository. Yeah? This is an official ROS2 repository. We can, you have the link right here. Let me open it. Yeah. So this is an official ROS2 repository which contains different packages with different demos about ROS2. Okay. So our snap is going to build and install this repository using the colcon plugin. Okay. Then from this repo, we are going to be using the Humble branch. Yeah? So this repo contains many different branches, as you can see, but the one we are interested in is Humble for our snap. Okay? So we specify as well the source branch of the repository. Okay? Source subdir. Yeah? In this case, this is the demo nodes CPP package. Yeah? This demo nodes CPP package that you have here is the one that contains the demos that we are going to be running. Yeah? The demos that we are going to be, I am saying the demo now, but the application that we are going to provide in our snap is from this package, demo nodes CPP. Okay? And finally, stage packages. These are some extra dependencies that we are going to need. In this case, it's ROS2 launch. Okay? So let me review a little bit here to make sure that I'm not leaving anything outside. Yeah, so here we are reviewing the stage. So Snapcraft relies on well-known and well-established ROS tools, such as, in this example, colcon. Yeah? So the packages we're building must have install rules, or else Snapcraft won't know which components to place into the snap. We should make sure we install binaries, libraries, header files, launch files, etc. Here we selected the Humble branch of this repository as source branch. Since ROS2 demos contains multiple packages, we select demo node CPP as the source subdirectory entry. Yeah? So this demo repository contains many packages inside, but actually the one that we are interested for our application is this demo nodes CPP. Yeah, so we set it as source subdir. Then we notice that ROS2 Humble, ROS2 Launch is listed as stage packages. Yeah, these are stage packages. Stage packages are packages required to run the part. Usually, this exec dependency is missing from the package XML, hence we must specify it. The rest of the dependencies are going to be automatically downloaded with rosject based on the package XML. Yeah? So here inside the package XML, we already have specified many dependencies which are going to be handled automatically. Okay? Yeah? And then let's review the last part, which is the apps section. Yeah. So this app section is actually what the end user is going to have access to. Okay. So far we have metadata, security things, parts, which is related to the building process. But these apps actually are the apps that the end user is going to have access to. Yeah. So in this case, we are creating one app which is named ROS2 Talker Listener, okay? We could create many more applications, yeah? In this case, it's a basic example, so we are creating only one application named like this, yeah? Then this application has a command, yeah? So whenever a user uses this application, the command he's going to be executing is this one, yeah? So actually, he's going to be launching this launch file, Talker Listener launch py, from the demo nodes CPP package. Yeah? And finally, in extension here, we have the dependency, so what is needed in order to run this command. Yeah? In this case, the extension that we are specifying is ROS2 humble. Okay? So in order to be able to execute this command, we need to have ROS2 humble installed in our Snap. Okay? Yeah? So let's review this very quickly as well. So the entry under apps is the app name. In this case, ROS2 Talker Listener. Yeah? That should be exposed to the end users. In a Snap, an application is usually prefixed by the Snap name, so the application my app from the Snap my Snap can be executed calling my Snap my app. Yeah. Yeah. But if the name is repeated, like in this example, we will have ROS2 Talker Listener and ROS2 Talker Listener 2 times. So this can be abbreviated. Yeah. So this name, ROS2 Talker Listener, the name of the app is the same name of the Snap. You see? Then, in order to call this application, we will have to do something like this: ROS2 Talker Listener dot ROS2 Talker Listener. Yeah? So the name of the Snap and the name of the application. But when both names are the same, this can be abbreviated to this. Okay? Multiple applications can be defined within the same Snapcraft YAML. Yeah? So here we could define many different applications. Our Snap will then expose multiple commands. Yeah? Then after the app name, we find the command entry, this entry here. Yeah? This specifies the path to the binary to be run, along with arguments. This is resolved relative to the root of our Snap contents. Then finally, the ROS2 humble extension, yeah, this extensions line, will set our ROS2 humble build and runtime environment. Yeah? So in order to be able to execute this command, we need a ROS2 humble system working. And that's it. Yeah? Then well, actually, let's start building, okay? Let's start building our Snap, because this is going to take some more time. So, very quickly, let's scroll down here to the building section, okay? And execute this command here. Yeah? Snapcraft enable experimental extensions to 1 and Snapcraft. Yeah, so let's copy this command here and run it here, okay? This is going to take some time. Well, actually, no. Wait, could not find the Snapcraft YAML. Are you sure? Ah, yeah, we are missing. Yeah, so this command, in order to build the Snap, has to be executed in a specific folder. Yeah. In this case, this folder is. Let me go back here. Is here. Yeah. So we need to execute this command inside this folder. Why? Because this command is expecting to find this Snap folder with the YAML file inside it. Yeah. So if you execute it somewhere else, it's going to fail, as you can see. Yeah, because it cannot find the YAML file in the expected path Okay, so now yes, now we can run it, and this is going to start building our snap. Okay, then let's leave this working here. Okay, and let's have a quick review of the contents of the YAML file. Yeah, so actually, yeah. So remember, the Snapcraft YAML file has, first of all, some metadata, very important in order to distribute our snap. Yeah, because once we build our snap, we are going to distribute it to other users. Then this metadata is going to provide some information about our snap to other users. Okay, so very important. Then we have to specify a confinement mode. Remember, this is related to security. Okay, and a base. Yeah, in order to provide some basic libraries. A basic Ubuntu system with the minimal basic libraries. Okay? Then we have the parts section, which specifies how to build our snap. Yeah? And here we are specifying the plugin, we are specifying a repo, we are specifying the branch of this repo that we want to build. We provide a source subdirectory with the specific package that we are going to be using. Yeah? And stage packages with any additional dependencies. Okay? And then finally we have this apps section, which is the one that is going to define the end applications that our snap is going to provide to end users. Yes? Let me come here to the chat. Yeah? So far so good. Are you following? More or less? Yes, no? Questions? Are you building your snaps? Like me here? Are all of you building your snaps? Chelsea says yes. Bipin says yes. Yes, building the snap. Great. Okay, perfect. Then, yeah, this is still building. So meanwhile, let's have a quick look here at the building process. Yeah. So we have reviewed all this. Then section 1.4.2, building, installing, and running a snap. Yeah. So now that our Snapcraft YAML file, this one here, is ready, we are going to describe how to build our package, our snap. Yeah. Then the Snapcraft command, this one that we are running right now, is expected to be run at the root of our repository where we can find the snap directory. Yeah. This is the issue that I had right here. Okay. So this is expected to be run in the root of the repository. The Snapcraft command is going to look for the Snapcraft YAML file and start building our snap. Okay? So Snapcraft is building the snap in the following steps. First of all, we have the pool, which downloads or otherwise retrieves the components needed to build the part. Yeah? In this case, it's going to download here this repository, right? Also, it's going to be getting this Core 22 base, snap, ROS2 Humble extension. Yeah. So it's going to download and retrieve everything needed for running the snap. Needed to build the part. Yeah, which is this here. Okay. Then build step, which constructs the part from the previously pulled components. The plugin of a part specifies how it is constructed. Yeah. So in our case, it's Colcon. Okay? Yeah? Then stage. In this step, we copy the build components into the staging area. Yeah, this is the first time all the different parts that make up Snap are actually placed in the same directory. And finally, we have the prime step, which copies the staged components into the priming area to their final locations for the resulting snap. This is very similar to the staging step, but files go into the priming area instead of the staging area. The prime step exists because the staging area might still contain files that are required for the build, but not for the snap. Okay, so now, as you can see, while we are building our snap, all these different sections are being created as directories here. Yes? Yeah, remember, initially we only had this snap folder with the Snapcraft YAML file, right? So now here it has appeared a parts folder, a prime folder, and a stage folder. Yeah? Then here it also says that for the moment, the ROS2 Humble is an experimental extension. Yeah, this extension that we are using here, it's experimental at present. Okay, this is why we have to use this environment variable. Snapcraft enable experimental extensions and set it to 1. Yeah, because right now this extension is experimental, but in the close future, it's not going to be needed anymore because it's not going to be experimental. Okay. Then, so we have the Snapcraft command, which we are executing here. And I think this is almost done. Then once it finishes, we are going to see a message similar to this one here. Yeah? Which says, once it finishes, we are going to see a message like this one. Created a snap package, ROS2 talker listener 01, amd64.snap. Okay. Let's go back here, and that's it. Yeah, it has finished. Here we get the message: created snap package ROS2. Okay. So right now, using our Snapcraft YAML file, we have built our first snap. Yes. Okay, this error, don't worry about this error. You can read here, it's expected. Okay, here it says unable to determine library dependencies. Yeah, don't worry because this is expected. You can just ignore it. Okay. Yes. So have you built your snaps? Still building? Have they finished building? Finish it, says Amna. Finish it also, Bipin. Okay, perfect. So we have built our snap. Then what is the next step? To install it. Yeah. So now we are going to install the snap that we have just built. Yeah. Then to install it, all we have to do is to run this command that we have here. Yeah. So let me copy it and paste it here. Sudo snap install and the name of our snap. Okay, and here in this case we are setting the dev mode flag. Yeah, this is because our snap is currently not confined. Yes, our confinement is dev mode, so this is why we are using this dev mode flag. Okay, then since we could install snapd on our current distribution, it means that we can install our freshly built snap. We don't need to be running Ubuntu to run this ROS2 Humble snap. We don't even need to install ROS on our host system to install and run the snap. Yeah, so this is very important. Okay, so we don't need to have ROS installed in our source system. Yeah, not even Ubuntu. Okay, in order to be able to run our snap, to install and run the snap. Okay, very important. Then snaps bundle all their dependencies as well as their core, which make them host agnostic. Okay, very important. Then we install our snap, and then the next step is to run the snap. Okay, so how are we going to run our snap? In this case, we only have one application, which is this ROS2 talker listener. Yeah. So if we want to run our snap, we are going to execute this application. Yeah. So we can type here the name of the application, which is ROS2 Talker Listener. Yeah. Then what is this command going to do? Basically, it's going to execute the command that I have specified here inside the application. Yeah. So let me execute it right now. And this is going to start running a listener node, a ROS2 listener node, and a ROS2 publisher node. Yeah. We have a publisher node, as you can see, which is publishing this message, hello world, and an integer, and we have a listener node, a subscriber, which is reading this message. Yeah. And right here, I have a ROS2 publisher and a ROS2 subscriber running in ROS2 Humble in my Snap. Okay. So in the system, here in the system, I don't have installed ROS. Yeah. So everything is running inside the Snap. Yeah. So we can also run the snap info command. Yeah. Snap info ROS2 Talker Listener. And this is going to provide me some information about this snap. Yeah. So the name of the snap, a summary. Yeah. This is the metadata, remember? Yeah. This is specified in the metadata, for instance. Yeah, a license, a description of the snap, the commands available. Yeah, in this case, we only have one command available because we have only defined one application here. Refresh date, install it, etc. Yes? And right now, you could already upload this snap to the Snap Store and distribute it very easily. Yeah. And anybody who wants can download this snap, install it, and start running it in just a couple of steps. Yeah. Very, very easily and very, very fast, and host agnostic. Yeah. So here I think that there was a link here to the Snap Store. Here it is, I think. No, this is documentation. Yeah, so through all the notebook, you are going to find many links to additional documentation. Yeah. So shared memory. Let me see if I can find the link to the store. Let me make this bigger very quickly. Let me see if I can find it. Was node from GitHub. Snap Store. Here it is. Yeah, here. Yeah. So here you can see many snaps that are already uploaded to the store and that you can download and install and start using. Yeah. So you can see Spotify, Slack, tools for development like PyCharm, IDE, Eclipse, Sublime, even games, as you can see here. You can download them as snaps, Slack, Skype, many tools, yeah, that are already provided. And of course, you can create your own snaps, which contain ROS2 applications, upload them here, and distribute them very easily to whoever you want, to your clients, to whoever you want. Yeah. Finish it building. Yeah. So have you been able to run also the snap and everything? Yes. Yes. Says Chelsea. Okay, excellent, great. Then, yeah, so as for the class, I'm going to leave it here, okay? Right next to all these, you have the section about confining, very interesting, yeah? And you have more sections down here, how to run your Snap as a daemon. You have some exercises as well here. Everything very interesting. So, but I'm going to leave the class here, and you can continue doing the unit, going through the unit by yourselves, okay? So this unit that we are working on is completely free. Anybody can access it. So you can keep working on the unit by yourself, okay? I think that with this class, we have set a good starting point so that you get a general idea of what are snaps and how useful, how they can help you in your robotics development. Yeah, this was the idea. So now, in order to keep learning more about snaps, I encourage you to keep working on this unit by yourselves. Okay? Yeah. So yeah, then I'm going to leave it already here. I hope that you enjoyed the class. I hope that you have learned something. Again, I want to thank the guys at Canonical, our friends at Canonical, by creating this amazing course with us. And yeah, I hope that you enjoyed it, that you liked it. I hope that you're encouraged to keep learning more about snaps. And yeah, that's all by my part. We have a last. So the snap can, Chelsea saying, so the snap can we create it today can be used on machines running OSs other than Ubuntu? Yes, they can, Chelsea, yes. Exactly. Snaps are host agnostic. They don't care about that, okay? Yeah, so, all right, then thanks a lot. I will see you again next Tuesday, probably in the next open class. And yeah, as always, until then, take care and keep pushing your ROS learning. Bye-bye.